Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is cyclic shift minimization. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. We are given a permutation P of size n that will contain the elements P1, P2 till Pn. This will consist the elements 1 to n and they will occur exactly once. We define function of P as the number of fixed points that has Pi exactly equal to I. That is, the index value is equal to the element's value. Now we call a cyclic shift of x when we shift all the elements x to the right. Note that they are going to be exactly n cyclic shift. Now in each cyclic shift, we will calculate the function of f of p. Now we define the function g of p as the maximum value of f of q functions. Q is nothing but the cyclic shift of all p. So we have this permutation p. For each shift that we are going to do, the shift are going to be 1 to n. So there are total n shift. In each shift, we'll find what is the number of fixed point where the index is equal to the element itself. And to get the function of g of p, we simply need to find in which we get the maximum number of fixed points. So we have to construct a permutation of size n, which will have the minimum value of g of p. That is, in each iteration of cyclic shift, we'll calculate the number of fixed points where index is equal to element, and over the cyclic shift, we need to find which is the minimum value. For the input format, we have t test cases, and for each test case, we'll have a single line that will contain the integer n. As for the output, we simply have to output the permutation that will give us the minimized value of function g of p. As for constraints, number of test cases will go from 1 to 500 and value of n, that is the number of the permutation array length, will go from 1 to 500 as well. Let's see some sample inputs. So for the first sample input, the size of the array is 1, means there can only be a single element. So there is nothing for us to permutate. Therefore, the answer is nothing but the same array 1. For the second array, that is n equal to 3, we can construct an array something like this: 2, 1 and 3. Now if we rotate 3 times, let's see what would happen. If we rotate it by 1 to the right, we'll get something like 3, 2, 1. If we rotate it again, we'll get now 1, 3 and 2. And lastly, if we rotate it again, we'll get 2, 1, 3. So we are back to the original permutation. Now if you see in this permutation, this is the original indices, right? 1, 2 and 3. In the first, there is one match, that is, there is one element that is equal to the index. In the second, we again also have a single element, and even in the third, we only have a single element. So for each of this permutation, maximum number of points where the index is equal to the element is just 1. And since the maximum of this is also 1, this is the best case scenario, right? So this is the permutation that we can give. Let's see how we can approach the solution. So let's assume that we have these n places, this n indices that we have. And let's assume this is the I index and this is the element I somewhere in the array. Now since we know that we are going to do n shifts, eventually at some point of time, this element, right, let's call it E of I, at some point of shift, it will come to the index I, right? And in that shift, we can match that this element is equal to this index and the score will increment by 1. So the minimum that we can have is that in any permutation, the maximum number of points that touches or is equal to the index is 1. So this can happen for odd numbers as we have seen in 1, 2, 3. Let's see if we can do this in even numbers. Let's take the example of 1, 2, 3, 4. So I'm starting with this. This is the base case, right? These are the indices. Now let's say we shift it once. If I shift it once, this becomes 4, 3, 2, 1. We do one more shift, right? Sorry, this is incorrect. If we shift it once, this will become 4, 1, 2 and 3. If we shift it once more, now this becomes 3, 4, 1, 2. Let's shift it once more. Now this becomes 2, 3, 4 and 1, and finally it again comes back to 1, 2, 3, 4. Now if you see in this 4, 1, 2, 3, none of them are matching. So in this case it is 0. Next if we see again none of them are matching. Here also none will match, but finally it will come to as 4. So in this case this is a bad permutation because at the end all of them are coming to the same index. So this is not good. But what would happen if we start with reverse? Again, these are our indices 1, 2, 3 and 4. Let's start with reverse. We have 4, 3, 2, 1. This is the first permutation. Now if we shift it once, this will become 1, 4, 3, 2. If we shift it again, this will become 2, 1, 4, 3. If we do it again, now this becomes 3, 2, 1, 4. And finally, this comes back to 4, 3, 2, 1. Now if you see, at any point of time, in this case, 1 is here, right, and 3 is here. So 2 points where the index is equal to the element. Again, next case, 2 is not equal, 1 is not equal, 4 is not equal, 3 is also not equal. In this case, it's 0. But in the third, 2 and 4 are at the same place. So again, it becomes 2. And again, finally, it's 0. So now you can see that the maximum here is 2. So for odd, for even, there is not much that we can avoid. In any kind of permutations, we have 2 points where the index is equal to the element. Whereas in odd, we have that one element is equal to its index in the permutation. So what we can do is we can simply print the elements 1 to n in the reverse order. For odd, in any kind of permutations, the maximum that we will get is 1, and in even, the maximum that we will get is 2. So with this arrangement of printing 1 to n in the reverse order, we get the minimum touch points where the element is equal to the index. And with this, we'll have our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve, take the input of n, and print the elements 1 to n in the reverse order, going from n minus 1 till 1. And as you can see, I've got an AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n, then print the numbers 1 to n in the reverse order. And I've got an AC in Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.